Okay, so we're looking at other types of energy. So we've got elastic potential energy. So that's energy that's stored through stretching or squashing. It's called elastic potential energy. Okay, so it's got the potential to move something. So bungee jumping, it's your classic. So the thing is you've got potential energy because you're up high. You're coming down, so your kinetic energy's increasing, and then all of a sudden, when it hits to the end of the elastic band, or the giant elastic band, then as that's stretching, so as the elastic band's stretching, that turns into elastic potential energy, and then you get to the bottom when it's stretched, and then that turns it back into kinetic energy. So when it's stretched at its furthest amount, it's elastic potential energy. Trampoline is the same. So when you're jumping on a trampoline, as you go down, all these springs get stretched. So that's turning into elastic potential energy. When it hits its furthest point, it's got maximum potential energy, elastic potential energy, and then it springs you back up. And so you'll turn that potential energy into kinetic energy as you fly off. The old pogo sticks, that uses elastic potential energy. So as you jump down, the spring's getting compressed. At the bottom, it's got the most elastic potential energy. Then it releases and springs you back up. So turns it into kinetic energy. A basketball or any sort of ball, when you drop it, as it hits the ground, it actually squashes. Okay, so that squashing will then, it's like if you imagine a spring being squashed, so the ball's getting squashed, then it wants to go back to its normal spot. So it expands, and as it expands back to its normal, it comes back up. Now, most balls won't rise to the same height, and that's because every time it hits the ground, it loses some as energy as heat. Okay, so heat energy is what we say dissipated. If you have bow and arrows or rubber bands or anything, as soon as it's stretched, that's turning into elastic potential energy. So it's got the potential to do some work or to turn into other energy, and that'll give the arrow kinetic energy once you let go. The old slingshot, so this works the same as bungee jumping. So when it's pulled down, you've got maximum elastic potential energy in the springs or string, whatever, giant elastic band, and it turns it into kinetic energy. So chemical potential energy. If you think of sports energy drinks, so they've got chemical potential energy. When we drink those, that energy the chemicals in that goes into our stomach, and we've done body systems, and we know the process there, and it takes some of the energy out. We've got batteries, so all sorts of batteries will store chemical energy because they've got chemicals inside them, and when they're connected up to a power or leads or anything like that, then it turns it into other sorts of energy. Fuel, petrol, diesel, all sorts of fuels, that's chemical potential energy, turns it in kinetic energy when we've put it into our cars and end up moving along. Gas is potential energy. Basically, while it's sitting there, it's chemical potential energy. Once it's lit, then it's obviously turning into thermal energy, a different sort of energy, but it's got potential as a chemical. And food, okay, so food has got plenty of chemical potential energy, and then once we eat it, that energy gets transferred from chemical potential energy into muscle kinetic energy and all sorts of different energies in our body. Nuclear energy. So nuclear energy, that's the energy stored in the tiniest of atoms. So inside the nucleus of the atom, there's protons and neutrons, and they're held together by a nuclear force. And when that force is broken, or when the protons and the neutrons are split apart, a huge amount of energy is released, and that's in the form of radiation, heat, and light. So it's the energy inside basically splitting the atoms. And if it's uncontrolled, then obviously we get a nuclear bomb. If it's controlled, Then obviously we can use it for nuclear power, nuclear medicine, and a whole lot of other positive things, but the thing that people think of is the negatives of nuclear energy. We've got light energy or solar energy, and if we think about it, sunlight and its energy is essential for all life on Earth. So without it, it's doubtful whether life would exist. So we realise we really do need our sun, and without that, the food, plants, trees, and that wouldn't grow, and we'd have no food. We also use light energy to actually see, and we sort of create that through various chemical means, electrical means. There's a whole lot of ways that we do that, and a lot of the energy that comes out of the light is actually heat, and then only a small amount of light. We've got solar energy as such, solar panels to create electricity. So yeah. Electrical energy, so we were just talking about that before. So we'd find it very hard to live without electrical energy these days. So we all know that one. But lightning is also electrical energy. So if you think about that, that's electrical energy has got to do with the electrons whizzing around and the movement of electrons. And static electricity, that's an electrical energy. If you have little bits of paper on the floor, on the table, and then you rub a balloon, you're causing static electricity, which is the movement of electrons. And even in the power here, in our power cables and wires, the electrical is the movement of electrons. So it's sort of like a kinetic energy, but it's in regards to the electrons moving. We've got sound energy. Okay, so sound energy is made when things vibrate. So energy is needed to make sounds. So sound energy is really a type of kinetic energy. So if you've been close to speakers and that, you notice that they vibrate. And then we can hear it, and that vibrates the sound waves go into our ears, and then it vibrates our eardrum. So that's how we hear the sound. If you think about a guitar, okay, and things like that, when the string vibrates, that actually causes the sound, so we get sound waves. So it makes the particles in the air move, and then it gets to our ear, and those particles move our eardrum. We've got heat energy or thermal energy, and so thermal energy can be generated by friction, and if you rub your hands together or tyres on the road or anything like that, it tends to get hot, and that's where heat energy is often dissipated, so it goes out into the atmosphere. We use thermal energy for cooking. Okay, so if you think about every time we cook something on the stove, there's thermal energy. Tyres on the road, this guy's doing burnout, so if you felt the tyres there, they'd be extremely hot after doing that. So, and that's got to do with the friction on the road. So remember that there are many types of energy, and each one can transform into another. But the energy in each system is the same at the start and at the end. It can't be created or destroyed, and that's something that you really need to keep in mind. We do note that heat energy is said to be lost, and that goes to the atmosphere and things. So it may seem that energy is lost, but it's just that it's hard to capture or measure it in some systems. So we keep saying energy is lost, but really mathematically it's not. It stays the same. It's just that it gets lost into heat energy or transformed. There you go.